Hello, today we're going to make a new video about how to build DOS cross torsion. Okay, DOS torsion. So you might say, well, why we still use DOS today? Because yeah, some systems are still using this DOS, right? Just old legacy DOS, whatever. Let's just compare it. So by doing DOS, we need to use DJGPP. If you haven't know how the cross torsion is going to build, you need to watch my last videos. I have previous videos about how to build cross torsions, but today we're going to make a new video about just building a cross torsion very simply. Okay, I'm not going to teach how exactly the process going. What we are going to do is to emulate the process. Okay, so when you first need to do is go to this DJGPP. You just go to search DJGPP, and it will tell you will go that side. We go to the current whatever in the mirror, whatever you want, and then we go to the DJGPP. We see we have a bunch of files here. I think this is probably the pre-compiled build, but we want to build the stuff by ourselves, right? I'm not going to build the Canadian cross compile, and I don't suggest you to build a DOS Canadian torsion either, because it does not work the way as we normally expect it on other platforms due to the restrictions of the DOS file path. They have a very short file path on DOS. So we go here, we click this DJCX CJX 205. Then we right click and we extract here. Okay, then by doing so we can see that we have a bunch of these files here, but yeah. So let me think how to compile it. Do I actually have a makefile, right? I actually forgot how to do that. We just try today. Okay, I don't think it's that hard. It should be makefile here. Let me see. Yeah, it should be makefile. Start DJGPP. Yeah, plus field. Target. I32 and then stop. I5 for oh yeah, they already have precompiled binaries. It's very simple. All we left to do is just to building her stuff, build up with the VJC-X we have, then I think it's very easy. You can make it very easy to finish. It can very easy to do this. Let's just start, okay? So first we go to bin utils 3db, just like what we did in the previous video. And we go GCC to go GCC git port, make sure we are running on the latest version, and then we start to build our torsion. Now we have two options. Now first option is that let me think, can we just directly build that? Probably we can. Okay, then just build a Linux torsion. So we could create a die code DOS torsion. Then we go to the DOS torsion. We start with. Oh, sorry. We start with Linux. So we just go Linux because we first need to build Linux, then build on Windows. And just the last compiler I built, remember? And we go to bin utils 3db. Okay, we config ls error. We don't actually need to build libc++ anymore because there's no libc++, right? And let me just check what the command I did in the last previous video. Yeah, we can just use it. Just use the. Hey, why? Okay, we do this. Disable SJLJ exceptions. Alright, I forgot to do one thing, which is we need to set target, right? In this first set target. Target is 100. Yeah, I5A6. Okay. PC. I don't think we actually need PC. Let's just call DJ GPP MS-DOS DJ GPP. Okay. It's very simple. We don't actually need to use PC MS-DOS DJ GPP. We just make it simple, right? And we can use the prefix. A prefix it should be is this directory and my home GCC DOS origin. You just use a Linux build. Okay, no, I just under this folder, right? Let's just put on this folder with target. Let me think. Yeah, it should work. Let's just prefix. Okay. Then we go export path equals path prefix the bin echo the path here. Okay. So then we just do the thing we wanted. I don't want my voice to be too loud because it's very late right now. It is 0 a.m. Okay. So I think what we need to do is just compile the code. I don't want to speak too much here. Okay. So let's just use the target. Then with prefix, I think we should done. It's done. I think it's done. Let me see whether we did done. Okay, DJ GPP. It detects what we're doing, and we call make J. It should take us 5 minutes, and okay. So when we are building the toolchain, we need to actually copy our files here. What we need to do is copy these two directories. Probably we also need info if we want. Manifest. We can just copy these files if you want. We just copy these files here. See with a stop here. I think what we only need to do is use a stop. DXE is that some kind of CRT, but alright, I understand why we have such a large binary size. It's because of this symbol here. It actually linked with the symbol and they can make files here. Yeah. I really want to see whether we can just making the CRT smaller because I actually don't need any debugging information. I don't want debug print anything. But clearly this still debug print something. Heavy H support. Okay, whatever. Net fix this directory and finish. Let me see whether we can just remove the debugging here. I don't want any debugging here. I don't want debugging because my binary size, I want a small binary size. I don't like large binary size, which is not good. Okay, which is not good. But okay, it doesn't seem we have. Oh, okay, we actually linked with this file, and this file is pretty large. The main entry point with the process, whatever. Why the binary is so large? It's not fine. You know, it's actually not fine. And can we take? Okay, this probably generate DLLs. I think this generate DLLs, but it does not look like this. They actually give us the source code ability to see, but whatever. Let's just copy the file. Copy these two files. I think we already built that. Make install script and copy it to GCC2 .torsion. Yeah, we already have this new directory, I think. Okay. What? We are our torsion. Oh no, it's we are torsion. Wait. Okay. Okay, it's here. Okay. So after we build the torsion, we copy our files here. Okay, we need to copy our files in this directory. We copy these files. Copy. Okay, it actually is actually copying. And there's another stuff we need to do. Okay, we cannot just do this. It's just one extra step we need to do. Of course, you can use the last cross torsion we just built here, but C-hex execute why? Yeah, we copy this directory. We copy. You just this stop. Okay, we need to copy this stop. We need to copy this stop. Under the build here, we need to build something. Or we can just use a cross torsion to build this. I would like to just use the cross torsion we last build to build this torsion. I think I did. If you don't know how to build a Linux torsion, you can use a native torsion. You actually don't need to use a cross torsion like I did. I just want to make things simpler. Okay, it's just okay to avoid whatever. Let's just build all stuff. Okay, let's just build all stuff. GCC2 GCC. Yeah, it should be here. Oh no, I actually did something very wrong. I should put in the Linux folder. Just too many things here. I just quickly get things wrong. What we need to do is go to the stop here. Or we can just go both of them. Then we call make fire. We cannot actually make it. We just copy make fire, the dx, just make fire. Then make, oh no, we cannot make it because this requires a cross torsion. What we need to do is go here. We need to build this. Notice we need to build this with native torsion, not to use the cross torsion we used here. What we need to do is build a stub editor and build that with GCC, not G++. Okay, use GCC, and we need to use C2X. C23, do we have that? Okay, we only have C2X. Oh no. This requires us to copy all the files here just to build things. This looks ridiculous, but yeah, wait. Well, why? Okay, we cannot do this. We need to actually move in the directory into the directory here instead of just using partial directory. And we can either use a native torsion or using cross torsion to build the stuff. Okay, it's the other same. To be honest, I would like to just build here to show you, but I think a lot of people don't understand how to do this. I think I still need to show with native torsion. So we go to the DOS torsion, go to GCC2, it goes DOS torsion, and then we go here, we copy the directory here. We delete the SLC is not enough, we need to delete. We delete it, and we go here, we go DJCRX. Oh no, DJCRX. Then here we go SLC, we go to stop. Now we stop, we need to copy it. Okay. Then we need to go build this stopify. Okay. Now we have this two directory. We have these two things. One is stopify, and it's too small executable. We need to build them. Okay, we need to build them. Build them to here. We copy a directory. We just build the put our GCC torsion here. It should be here, right? No, not here. It's actually here. Okay, it's here, and we copy this stuff. Copy it here. Okay. Yeah, it should done. We should have done this. Let's just call stopify to see whether it has a stopify. Okay. Then the next step is actually build a torsion. So we need to go to build a GCC Linux. We need to go. This is not Linux torsion. It's just the GCC is running on Linux. Just that thing. There's nothing else to do. And we need to call this. We need to go target prefix and disable sjlj exceptions, disable leave stdc++ verbal, disable let me see what else we might lost, because I might lost something. Oh, enable languages. I think this is important. We need to only enable C and C++. We don't actually need other languages. Yes, we've done it, and we call make. We make it. It should. We don't need to do anything. We just make it, and it should just finish after we make it. Okay. I would like to see whether we can actually do something more interesting here, because I would like to not use the default CRT because the CRT file is too large. I don't know whether we can just strip the entire CRT here. I don't think you actually need 70 kilobytes just to run a DOS program. They have no reason to be such large, unfortunately. Oh, oh. Strip not needed. Oh, they actually provide a script here we can use, but yeah, this is just normal makefile. We can just call it makefile, and we don't bother, just make it, and here we go. Makefile. Do we need to make it capitalize it? I don't think we can. We just build it, and let me see. We can just build a CRT here. This should be CRT, but I actually don't want to link anything with the DirectX 3 because it is awful. It's really, really awful to use this. Okay. Why the CRT is so large? Register framework info. Do we have the register frame info here? Or it's here? No, it's not here, right? So this is ridiculous because okay. Yes, this looks like CRT, right? It really, really looks like a CRT function. But whatever. I don't think they actually open source the entire of their stuff. Okay, this is something that you can use if you just want to just directly use it. But in the CRT there. Something I don't actually understand here. I think it's actually because this libm is linked with the thing here, probably. I don't know whether they linked with libm by default. Can we just not link libm GCC? I think the main reason is because of the libm is by default linked with it. Okay, we can try it after we build a compiler. It should be very, very fast. It should not be that slow, and I think we're nearly done with building a compiler. Yeah. Yeah. Oh no, why? Yeah, this is exactly something we need to deal with because here is actually a bug in GCC with the stuff. Okay, what we can do is, but we actually need to do something to here. I did have a patch before just to deal with the problem here, but I actually even submitted into to libs to C++, but they haven't fixed it. So this is why we need to fix the bug by ourselves. Okay. So we go to config, we go to the OS, we go DJGPP, then we go OS define, we need to define a micro. I think it's just a thing I did before. Just go to Bugzilla. Let me see what bugs I reported here. Should be DJGPP. Yeah, here. So here we need to do it is to, you either can just manually use it, just see the patch here, we can just manually copy this. Then we need to do here, we need to copy here, and we need to, okay, yeah, we just use this patch. We need to use this patch before they fix it, before they actually fix it, but whatever, we can just I think we need to just download the patch instead of let me do this. Edit source. We just download it. I really want to download the file. How can I download a patch? I did it. But cache line. Yeah, it's a bug. It's actually a GCC bug. We need to fix it. And here we go. Go here. Go to this shepherd stuff. Okay, we need to go to GCC for directory. Then change the change the shared product. Go here, then go C++ 11 shared product. Okay, shared product. We need to fix the shared product. So we need to fix shared product with this micro. We need to first add this micro here, and we call it else. Okay, we don't bother do that, and we call static. Okay, we need to call static. Here we go. Okay. Now it should be done. Okay. I think we just commit it. We finish. The build will succeed. Be a success. And after that, we should finish it. Finish our build. Yeah, this is another bug. This is another bug. Well, the reason is that we cannot do this no supported here. It has no supported. Another bug, I think ID report no support bug here. DOS. You know, it's just using DOS. We actually need to fix this problem. Yeah, I actually remember. I forgot that. Okay, fixing in his build, but he haven't just fixed here. All right. It's not supported, and we cannot actually use the invalid argument here because on our target we don't have that micro, right? We don't have micro. The DJC access did not compile with it. What we need to do is go to the GCC here. We'll go to our GCC, our libc. No, here, just GCC. Where are GCC here? Okay, it might be in my home GCC. Okay, it's here. We go here. We need to do something. We need to modify the code. There's another bug we need to fix. It should be in error no. Yeah. Then go here. def POSIX. Then we go define I think it's eno sub eno spp. I think it's a mic. I don't know, ep eno sub or eno sub. It's eno sub spp. Okay, eno sp. Microsoft does not support eno sp. Okay, eno sp. Why? Oh, enough support. Okay, enough support is it's now we define as 41. Okay, we just define we need to define as 42 because you can see that here is they say we have 41 for illicit. It is set valid multi-bytes. Okay, I think we also need to define this micro too, so we can use it with libc to C++. Then we make it. It should finish. Yeah. Okay, we've done it. We can install script J. Yes, we've done it. Then we can try to build a hello world to see whether we can have this new hello world with it. Probably we might be able to run it with one. I don't know whether one can support the DOS programs. So we build it with IOScript. We build with i55 ms DOS DJ GPP G++ LCA fast native. Yeah, 1A. No, it's a DOS application. You need to run into DOS. It does not work. Okay, it does not work. But we can actually. Okay, so it, yeah, the compilation should be a success. It's successful. Okay, then just build. We need to build a Canadian crosstalk compiler because I want to run this torch on Windows. I don't want to run it on Linux. Okay. Yes, we have our greatest torch, and then we need to echo about prefix. We need to go to a new directory. Go to Windows. We need to fix our prefix with Windows. We just call it Windows. Okay, Windows. Then we need to use our glorious cross compiler with the build last day. And we go echo path. We go GCC. I don't actually remember what we did with our compiler in the last video. I think it should be here. If I remember correctly, it should be here. Yeah. No, it's not here. We can actually find our code with the it is here. It's here. Okay. It's here. They are here. Okay. Yeah, I remember. They are here. So it just needs to cross to go to. We need to use our cross torsion, not the Canadian cross torsion. Don't get it wrong. Okay. And after that, we need to put our directory here. Prefix equals no. Oh no, it's not prefix. Remember, it's not prefix. Okay, it is path. Okay, it is path. Yeah. Okay. Why do we need to do this? We need to do a test whether we can detect our G++. Yes. This is not a compiler we built. Okay, this is something. It's an old compiler because I've said I have a multiple version compiler. We don't actually need this version in the newer version. We remove that. Okay, we need to remove this. We need to remove it. code what doesn't collapse. Okay. Export path. Yeah. So we build with our latest across the glorious torsion. We go Windows. Okay. Oh no, here just okay. Just use any directory wherever we want. But what directory I did use before? DOS torsion. I think it should be DOS torsion, right? DOS torsion. And we make that equal Windows. Go Windows, okay. So the Windows did the same thing, but like Linux did, you need to go after x86, the MS-DOS, DJ, GPP, G++, and here what we need to do is call this GCC to do something different. Not the CC. It's actually to use ELD. When you first use LD, okay, we just use Bing YouTube. It already need to use GCC, but first we need to use Bing to build Bing YouTube. Okay. Use GDB config RS error disable W error target I59.6 MS-DOS DJGPP and host. And let's set host to x86 W86 Ming M32. Do you see our prefix? Okay, let's just see whether we set our prefix. Okay, yeah, we did set that, so it's not a problem. Now we use prefix. This prefix. We'll just disable all those nonsense. I don't think we actually need to do that, but there's something else we need to do. Disable GDB. Disable GDB. So see whether we yeah. Okay, this is an example of when build host target are not the same at all. Then again, we need to use this torsion. G++. Use the last torsion we just built to build the Stubify. Okay, build the Stubify. Go here. Go back to GCC. DOS torsion. Where's the Stubify? I actually cannot remember everything. It's too chaos. New leaf? No. Okay. Yeah. We can either use the British torsion. Or use a cross torsion. I think I just put the JCRX here. Where's the JCRX? Okay. Whatever, we need to use the DJCRX. Okay, so we go to the cross again. Across, do SLC again. Yeah, we need to do the Stubify. Okay, remember you need to use Stubify before doing so. Or we can use either GCC or Clan. We can use Clan to build it, but yeah, it doesn't make any sense. we better static compile it. I suggest you to static compile this because we're building Canadian cross-store chain. We might have issues with the stuff. So better just static compile it. Or we'll introduce a dependency with it, with deep through C++, probably. I hope we won't, but sometimes we will. C2x. Okay, C2x. No, it's not C. We need to just start edit. Yeah, here we go. I think this executable, yeah, it's a very large executable because it's static. No, I don't think the static compiles issues because the GCC issue. Now we need to build another Stubify with it. Now we have two executable with Windows executable. We need to build a new executable. Copy these two new executable to here, to GCC2. DOS torching. Stubify here. Here we go. Let me think about it. Yeah, this two executable. Go to, no, not here. Oh no. Oh, not here. Go to Stubify here. Copy here. This is our new executable. And then what we need to do is, this is a little bit different. We actually need to copy, why have 64? You actually build a 64-bit, okay. So then what we need to do is, we need to copy the CX to here. I hope I won't get things wrong. We shouldn't if the compiler isn't dumb enough to do that. But sometimes they will be very dumb. Copy this to back. Copy this directory here. Just copy totality here. Yeah. If you're living enough, you can just copy the file. But I think building entire stuff isn't taking too much time compared to this human intervention. Then what we need to just set prefix and host. We use set prefix and host. Here we go. Oh no, it's not here. It's the directory above that directory. It's here. Now here, I just make. Oh no, oh no. Assembly. 拍照的 print. People abusing OO to a very higher level. OO abuse is a huge issue. Relic, AR. Hashtag. And no exceptions, no RTT. It's synchronous at one table. Why do you just not disable the entire exception? It is very bad. Machine. GCC, GCC, GCC. Performance. Yeah. Sticky. Yeah, it's working. You shouldn't have no issues. And it is Canadian crossword compiled, and it will compile to the right place. Yeah. Yeah, then we make install strip J. Here we go. I think we've done it. Yeah. Here are our entire torch we just built it. So we now have two torches. One is running on Linux. This is the Linux cross torch and a Windows cross torch. To run this torch, we just copy. Don't move, just copy. Okay, move is not good. We copy here to something, to anywhere you think you have enough stored, right? You can see my storage is not enough, just only 66 gigabytes of D drive. That is not good. So we have our torch right now. Yeah, here's our torch. And we can use it to build our program. Okay. I want to show you how IOStream, how bad IOStream is. I just show you. Let me show you how bad it is. Okay, it is pretty bad. It's extremely bad in my opinion. You can first do this hello world with fast.io. Let's just see how large fast.io would be. I think I can actually strip it out with some stuff because I actually don't use IOStream. but why? Okay, it's not. We shouldn't do this. We need to give a prefix. Okay, that's how we use cross compiler. Then we do this. Yeah, if the code is correctly, we cannot find stubify, right? This is stubify here. That's exactly what I'm saying. We need to use this stubify, or it cannot build our programs. But yeah, here we go. I think what we can do is add this into the directory. The environmental variables, environmental path. We need to put the tooltip here. So not only we don't need to use this stuff anymore, we can just directly compile it. Okay. Yes. Why? Wait. If I did it correctly. Oh no, we not did it correctly. It must be Bing. Okay, we must put it with Bing. We cannot just put a directory here. We need to put Bing here. Looks like the environmental variable is not okay. You win. Okay, please, no, Microsoft, you win. Okay, you win the game. Probably we need to create a new directory with File Explorer. We might be able to use it. Oh, I did not set the path correctly for your account. No, we did not set it correctly. That's the reason. It does not set our environmental variable correctly, and we need to ensure we have set it correctly. Here we go, just compile it. Hello world, C, or fast, and not native. Okay, this is a new torture install my fast.io. Cannot run it. But okay, this native torture is not Canadian cross torture, or not cross torture. We need to use. I think this is ms-dos djgpp. With it. Okay, then we have the executable. You can see although we do have the executable Windows, we cannot run it. Why? Can we run this executable directly on Windows? No, because this is a DOS program. It cannot run on Windows. Okay. Remember, if it is a DOS program, you cannot run on Windows. Let me see. We can just use the default rates. Yeah, here we can see. Yeah. That's exactly, I think, something very problematic. They actually call F right, but let's just LC, see whether it can get rid of it. Then we can do LSTD C++, or L sub C++. No, not L sub C++. Or we just call L sub C++, L what? L GCC. But we still cannot find it. CRT0. CRT0. Oh no, we cannot just use CRT0. CRT, we actually we did not. I think we did not just stick with CRT. We actually really want to see whether we can just make the XT0 extremely small, but I don't know why it actually is so large. Spot. Why? Seriously, why? CRT0, GCRT0, probably working with GCRT0. Okay, instead of just doing that, we use Notepad. So we don't need to bother doing that anymore. .o. Okay, I think this actually has a correct order to do so. No, we cannot. We need to put here. Let's see. No, it still has the use area. It looks like it must link away as it is designed for. It cannot strip the symbol. It's sad. It is very sad. It's very sad. You might say, oh, 100 kilobytes. What about IO stream? This is exactly something why I hate IO stream so much. I hate it. Oh, I think I did create IO stream. Yeah. It's something I really hate about IO stream. Oh, remember, we cannot use Mach native because we're not running our program on computer, right? We cannot use it. Yeah. So the binary size is 606 kilobytes. This is unacceptable, to be honest. It's completely unacceptable because your executor is so large. It's so large, unfortunately. If you compare to FastIO, FastIO even in the exceptions is much slower than you have. Right? So, okay, then we have the executable. Something. So, how do we do this? We need to first set up drive here. We need to mount the drive. We need to mount D drive with d.hgfs executable. Yeah. Go to the D drive. We go to the D drive. Then we go hello what? Okay. Then we call hello. We call IO stream, whatever. No, it doesn't run. Call FastIO, call hello what? No, it doesn't run either, right? It doesn't run either. Right, it doesn't run despite we want it to run. Right. I will call it hello because DOS has a restriction on the size, binary size we can put here. We just call hello.exe, but we cannot use it. How do we do this? Well, this is something I would like to tell you how to do this. So I think we need to install CSDPMI or HPDPMI. HDPMI. CSDPMI.zip. When we are to get the executable, it will tell you. Then you need to download this executable here. Okay. Then now how to do this? Very simple. You just copy all these executable. Okay, copy all of them into the directory you executable you want to run the executable. Now we have this executable we can run. Yeah. Oh, the reason we cannot do this is that we did not mount C drive. So we can mount. We instead of mounting here, we actually need to mount the C drive here. C drive. Okay. Then we call IO stream. Yeah, it runs too. Because the IO stream is 6 times larger than our FastIO. We can actually make FastIO smaller by using fno exceptions, fno RTTI, fno on1 tables, no asynchronous on1 tables. So here it will be 60 kilobytes. Okay. The reason we have that is that they actually link to something we don't need. That's really unfortunate. I think someone should just rewrite this DRT. Okay, here we go. We have the executable. We have this IO stream here. I want to try some more complex examples instead of just the single example, which doesn't look very interesting. That's my favorite example about what about construct F string from from yeah, this can actually run even on the real world DOS. If you do DOS programming with an embedded system, you can use our fast forward to do this without DHCP. And we do this call I56. Okay. Oh, remember, we always had .exe on it will generate two binaries. Despite one is completely useless. Okay, this completely useless. Yeah, here we go. It's just our executable. Now we want construct. Can we dial it? Yeah, it should be two. Why it doesn't run? Oh no, why? Seriously, why? No. Oh no, oh no. What? So you should never ever use IO stream because it really blows binary size. You can see the binary size is ridiculous, to be honest. Mount our C drive to this directory. C drive, it says it doesn't exist. Okay, we do not use class IO. And we go to the C drive and we construct. Delete it. Okay, you still have so many executable. You might in huge trouble with the directory. Why can't I run command.x? This, all right, Microsoft cost. Let's go cost. Okay, cost. Why? 0 cost. Oh no, get killed. Why? Okay, don't put a mark native because it doesn't provide the structure, right? You get just directly killed by the process. Never use a mark native. Why? Opcode, illegal opcode. Okay, this is because we did not put an executable here. We did not recompile executable with cost. Yeah, we have. So we have the file descriptor, file star, and can we just put it? I'll put this larger. It's too small. DOS. Yeah, here we have the DOS here. We can see the time is incorrect, right? The time is incorrect here. If we just, it has some offset with the executable. This is because in the DOS, the time is not accurate. Okay, the DOS box has some issues, I think. That's why we can only run the program, but we cannot actually use it. Oh, okay. So there's another bonus here I want to show you. We can actually run in the DOS. We can run in Windows with VirtualBox. Okay. We can run in Windows 95 or Windows 98 with this executable. And I want to also show you how what about native? Okay, this costs just DOS. We just call it this DOS. Okay. Then we can use our native torsion to build another one. Use our native torsion. This is called Win95. Okay. But remember, don't put optimization level too high. And we cannot just use O2. Don't use OFast. Then we need to use M32. Then we call D32 Windows 0400. No, it's 00. Okay. Here we go. We have the one is cost, the other is Win95. Okay, we have two executable. Okay, so we copy this directory to no, it's 395. Yeah, this here, so 195. We cannot do this as just www. Okay, copy here. Notice that if we are running in the Windows 95, we don't need to call the executable. Okay, there's something I missed here. We cannot we cannot dynamically compile the Win95. We cannot dynamically compile, remember, okay? Because libc does not support this correctly. Instead, we just call Windows 95. Put www here. When we use running this not in real world mode of DOS, we don't need to run this executable. If we're not running in a real mode, we need to do this. Okay, just running this DOS command. This is not real world DOS command. Okay? So remember, it's different. It's very different from real world DOS. Then we run in the www. Okay, pause. Yeah, we don't need to use the real world mode DOS, but we can still run this program. And we can just run the same thing. This shows us the differences. We can see the first one should have a less accurate, and of course Windows 95 give us a better result, and then the DOS doing. Remember, they're not the same thing. Okay, the executable we are running in the DOS are different from the executable is running on Windows 95. It looks like the file descriptor of DOS is actually the handle on Windows 95, but it's not the case for modern versions of Windows. Of course, if you might say, can we just run this in a real world mode DOS? Remember, if you want to run in the real mode, you must provide those executable. If you're just running in the Windows 95, you don't. Then we just restart the computer and in the DOS mode. Let's just go to the real world mode DOS. Yeah, this is the real world mode DOS. When we go to start, yeah, then we run Win95. Okay, now Win95 with www. First, can we just run the Win95? No, we cannot run it because it doesn't work run in DOS mode, but we can run this in the real world mode DOS. Okay, you see this actually works even in VirtualBox. I think we're just putting a full screen. Oh, I hope I don't run in full screen, then it shows me something which is okay. Okay, this is real. Oh no, we cannot do this. Okay, don't do this. Oh, why? Seriously, why? Oh, it's so annoying, you know, just so annoying. Oh, we cannot accept. It blocks our computer. No, don't run in that form. Yeah, we can only run in this. Okay. No, we cannot run this, but we can run cost, right? We can run this in the real one, not in real mode, but in protected mode. No, we cannot do this because we're not running Windows, right? No, there's no Windows 95 because we are running in real mode. Can we just run the program, run Windows? I don't want command. I think we can just run command. No, it doesn't run. Auto exec. No, it doesn't run. So I don't actually know how to run Windows in the DOS. Okay. Don't actually seem to show us how to do it. computer, if we exit, it should just run when leaving exit Windows. Right? If we run execute, yeah, okay. We go back to our Windows 95. Let's see whether Windows 98 or Windows 95 would run. And Windows ME, because Windows 95 works, it should work on Windows 98, right? Okay. Let's just try Windows ME and Windows 98. So some issues with kernel 32. Now, we can actually just go to the directory here, because I actually set this up in the virtual machine. Then we call this command line. We need to use this DOS command in Windows ME. I don't think the executable would run in Windows 9, Windows XP. I don't think it would run in Windows XP because it's not DOS kernel. Here we go. We go to the www. No, we go to the directory. Oh no, it's too laggy. I think I enabled too much directory and probably need to close. Oh, it's too laggy. Unfortunately, we enabled too many. Okay. Virtual machines, and also we also okay, it's too laggy. Just we need to close the virtual machine. We need to close. Probably we need to first close the Windows 98. So let's just close Windows 98, and then if after we do that, we just going to test Windows 95. But let's just first test Windows ME. Windows ME. We need to test it on Windows ME. Yeah, we need to no, don't shut Windows 95 down. We need to shut the Windows. Oh, it's still too late. It more like it's not an issue in the host machine. It's an issues with Windows ME. I think we need to power this up, power off this stuff. Let's just reboot to Windows ME. Yeah. So SanDisk it's not blue screen is because it's the scan screen program running on Windows 90, not Windows ME. I should shut this down, but yeah, just shut Windows 95 down because we don't need Windows 95 right now. I'll just directly copy those files to see whether we can run the DJGPP inside ME, the DOS function inside ME. Yeah, then we can call this restore my execute. Then we use this Windows ME. Yeah, I just put them in the directory here. Okay, we just call it www. We copy. This is actually something which is very wrong with Windows ME is that you cannot enter real-world mode DOS. Okay, we cannot run in Windows real-world DOS. So what's the point of use this? It is so bad, you know, it's just very bad. This operating system is a very bad operating system. But sometimes it's good to use it to test programs that's sadly. Here we go, we can see Windows 95. Yeah, Windows 95 works. Yeah, cost work. Yeah. So we have our Windows 95 and our DOS. This is the DOS program, another Windows 95 program. Okay, so it runs on. Yeah, let's just in the lastly we just notice we don't have real model DOS. Okay, that's very sad. Then we go to the Windows 98. Finally, we go to Windows 98. I don't think OG kernel would run this DOS program in any meaningful way. It doesn't run. Okay. And we need to copy them into Windows 98. I really, yeah, Windows 98. Then yeah, we can run the www. We can just do the same thing. Copy the cost, the DOS and Windows 95 program, and we run this DOS program inside the DOS command. This is actually something different because I can create a directory in Windows 98, which is we might not be able to remember it after our reboot. But yeah, let's just first run DOS. It runs and run Windows 95. Oh, it has no Windows, no the stuff. It doesn't run. Okay, it doesn't run. So this is actually because it lacks of MSVCRT on Windows 95, on 98. You might say, why Windows 95 is not a problem? Because I did upgrade Windows 95. Maybe we can just upgrade Windows 95 the shell, the MSVCRT, but I don't want to do that. We can do that in safe mode. I think we can upgrade it to the new version of MSVCRT. But we cannot actually run this program because the MSVCRT isn't working. Okay, then just go to the, just put in the C drive. Okay, just put in the C drive. After we reboot it, we can see whether this program could run in a real DOS. Oh, we cannot run it. I can guarantee it doesn't run. The reason it doesn't run is that we did not copy these files inside the DOS. We can just try it, okay? But I'm afraid we're going to have a failure here. Yeah, maybe we could just copy the MSVCRT in the DOS mode to fix the issues too. Why? Seriously? Why? Power it off. Yeah, we don't need to do this. I think if we can just get a newer version of MSVCRT to run, probably going to be better. But yeah, I think we can actually probably the MSVCRT package could run this. Could actually run this, but I did not test it. Did it here? Let me think about it. MSVCRT. Yeah, probably we really need to use the Windows 95 versions of MSVCRT. Install that package on Windows 95, 98. It's funny, just running Windows 98 versions of Windows MS to Windows 95. 98, okay. Yeah, we just put it here. We don't actually need to run it because the server is already booting. I think, yeah. If you lack of this, you can just run this VCN redistributable C drive. Let's put C drive. CCRT, okay. Yeah. Now we should have a newer version of MSCCRT. It's too. Yeah, VC executable. Yeah. So if we have an older version of the MSVCRT, we can just upgrade it. It will upgrade our Windows, make it works. Newer versions of Windows, yeah, it will upgrade the settings because it's a very large update for the Windows. And here we go. I think we can just copy this directory. Yeah, don't why, because do you know why we have this stuff? Because it doesn't understand LF. We can use CRF, but let's just copy this www here. Go to www. We can go to profiles, Windows profiles. I think now we should be able to run our programs because we update the MSCRT. It should work. Cost. Yeah, it works now. So it's no problem with our old versions of MSCRT. Here we go. It runs. It's no problem. But we cannot dynamically linking with libc++. Okay, just don't use it. Please just don't use libc++. Use IOStream. Modify. Okay, still cannot run. Huh. Even when upgraded, it still doesn't run. There's no mstate64 here, which is pretty dumb. All right, this is MSVCRT. All right, it doesn't work. So yeah, we need to just reboot it in real world DOS to see whether. Okay, we need to go to the real world DOS. Then we go to desktop, and we need to go to www, the directory we just put here. We call cost. Yeah. So we run it in a real world mode DOS. And we can use the exit to exit this Windows, and it will bring us back to Windows 98. Yeah. Yeah. I think this is all about this video. We can just enjoy what the Windows 98 is. So we can just put another screen here because I know people would actually be very be nostalgic of this old stuff. Probably can just make you happy with it. You can just use it. I did not actually install the Windows 98 Plus packages. Oh, that's not good. I think this is another. Yeah, yeah, this is. Yeah, it's just nostalgic feeling of the background here. I think there's something probably everyone will be more nostalgic about it. Is this, I actually cannot see this stuff. Yeah, it's sad. But we need to wait for, we can just preview it. We don't actually need to, we don't actually need to set it. We can just preview it. Yeah, we can preview this. Okay, preview it. No, it doesn't run. Oh no, why? Yeah. Okay, we cannot see. I cannot see this 3D math because I will feel very uncomfortable when I see this. Okay, just pre-concept. Okay. So if you don't, you might say if it doesn't run on Windows 95 or 98, what thing you can do? It's very simple. Don't use IOStream. Okay, just don't use IOStream. We will be able to run our program. Just don't use IOStream. There's another program that doesn't use IOStream, which is just construct FP. Don't run IOStream, okay? And don't run, yeah. This is Windows 98. We just put it Windows 98 here. Here we go. I think we can actually, okay, just static compile it. Right issues. the binary size won't be that large. Yeah, it's only 83. We can actually make it smaller if we just run with just libs2 C++. It should be only around 10 if my memory is correctly. 53. This is actually because the binary below the stdio. Okay, you know, you might, in fact, stdio also blows because the printf here we're using here. Maybe not using IOStream, stdio, neither IOStream or stdio will be a better solution. Probably we just put here, we just don't do this anymore, just call stdio windows. Construct fp from it, but we don't call printf because printf blows our binary size. Don't run it. I think now we should have a very small binary size compared to what we had before. I don't think if we just think with the lib sub C++, we just compile it before it will run. Okay, it looks like it's running inputs, but yeah. What we can actually do, let me first try whether this program could work. Let me just do something else. Oh, don't remember to put here. Don't look as stupid as I did. We don't have the Windows 98 program. It should work. Okay, so if you want small binary size, please never use IOStream. Okay, please never use IOStream if you want binary size. Reduce your binary size. We go back to our DOS command. We go into our DOS command. We run it. Windows 98. Yeah, here it works. But if we try to static compile it, it's not working. It's not working because Windows 98. It might not work. I think it probably not work because we did not install the correct versions of libs sub. Please just update it. Despite it works, I remember if exceptions, we use different exception models. The DLL isn't installed correctly. Yeah, this is the last stuff we just built. Then put these DLLs. I think libs2 C++ does not work. You don't need to copy libs2 C++. Just copy lib sub C++. This DLL, we need to copy those DLLs here. Some DLLs. Quad mass. Okay, they just lib sub C++. I think the most DLL we need here is the quad mass. Yeah, we just call lib GCC. I think lib GCC should be enough. Okay, let's just copy all DLLs. This while the DLL is too large. DLL, we just copy it. Despite we have this DLL, please don't run IOStream. It doesn't work. Okay. Now we copy our DLLs here. Then we run this executable. We copy those DLLs. Oh no! Why? Seriously? How to get this run? Oh no! Close it, please. Close. Yeah, close it. Now what we need to do is copy those executable size system, not system32, but system directory. Okay, we need to copy those DLLs, all these DLLs. Okay, copy them. Okay, no need to this static library. We don't need it. We copy all these DLLs inside the Windows system32. There we go. We should run it with no issues. Okay, we know how I did executable running in the Windows 98 with the latest C++ and the library. Let sometimes you can run something interesting, like networking. Can we just run the TCP client inside Windows? We can. What we can actually do is running a Windows TCP server inside Windows 95. Okay, we can actually do this. I think if we, no, I cannot do this because I just recently just overhaul the transmit function. We cannot do this. But we can. I think we can actually call this DNS function. We can call this DNS. We can get our DNS to see whether we can do a DNS query, and then we can do it later. I didn't write the code. Okay. So not very interesting. I will show some interesting example here on Windows 95, but it doesn't seem we can run something interesting. The only thing probably interesting is this construct f-string stuff. POSIX clock and time. Okay, that's it. That's it. I think this video should be very interesting to you if you found old operating system like I did. I don't actually like Windows 11. I think it sucks very badly. But we can actually run Windows 98. Okay. The protected mode is not accessible. Yeah, not accessible. Protected mode. So this difference between these, despite we're running Windows 98, is they actually not quite exactly the same. Yeah, it looks like it brings us to old memories of Windows, the old versions of Windows. We cannot run this because it cannot run in DOS mode, but we can run in Windows mode. Run in the DOS mode. Yeah. So if you're running on Windows 95, you can either use DOS command. You can either use DOS or using GCC or MIGWin. Both of them should work. There's something I'm not quite sure about, is that whether client can work. I think client doesn't work on Windows 95, 98. Client doesn't work. No, it does run on Windows 95 and Windows 8. It doesn't run on DOS. There's a lot of reasons why we still have to use GCC, because only GCC could run on DOS. Running on DOS. Okay, I think we need to just, here's the old version of Windows. It looks like I probably did it because I installed. Okay, nothing problem. Yeah, the only problem is that we don't have IO stream. We don't actually need IO stream, to be honest. It sucks. It's awful. IO stream is awful and shit. Even the binary size, you can see the binary size is it's ridiculous, right? If we run this executable, you just compare this to executable. It's 32 kilobytes and it does wrong. Not unlike IO stream, even with 95 kilobytes, it still does not run. It does not run. It's not working. Okay. It's not working. That's unfortunate. You must say, what about we run another program? Yeah. If we run FP, just run FP, what's going to happen if we run with GPP torching? Oh, Windows 98. Windows 98 BGA GPP. Don't run M32 because now we are running on I guess O2 optimizations. People will run O2, right? Yeah, seriously, we could run on Windows 2, but oh, I'm still running Windows 95. Okay. Shut it down. Yeah, we just use Windows 98 as example. Okay, it's just testing on Windows 98, and Windows 95 is exactly the same. They don't have much difference. The only difference is probably the error versions issues. Yeah, I just compiled our code inside here. This is actually my favorite example. In Windows, the fast IO is to run this executable here. Is to run what? Okay. Run Windows 98 DJGBP. First, the executable of 171 because we introduced dependency, but it's still smaller than IOStream, right? IOStream, seed IOStream. It is very bad IOStream. 607 kilobytes. Why? What the fuck? Just the only thing to say is that we have zero reason to use IOStream at all. Just bring the SLA awful. Really, just awful. Just bring the SLA awful. I don't understand what's the program going wrong? Why? Okay, I think the reason is that this program is actually installed in the www directory. We don't actually need to copy this. It's just if we're gonna run it, we're gonna run with the first. We don't actually need this executable. DOS. We just put in the real one DOS. Oh no, it's illegal operation. Yeah. Illegal operation. Restart to Windows, to profiles, to desktop, to yeah, to okay, desktop to Windows 98 DOS. Okay. This DOS F string. Now, if we run without IOStream, yeah, it also runs, but we don't have IOStream, right? We don't need IOStream at all. This is the executable is going to run. It's just issues with the virtual machine. I think Windows 98 is an operating system which is extremely unstable compared to Windows 90, 95. It's extremely unstable. Okay, I think we can go into a trap of die this. Okay, we'll just get rid of it. I mean the MS-DOS mode. Yeah, we run Windows. Not this actually, it's actually Windows 98. I did put the directory here. So if we run Windows 98, it doesn't run, but it runs DJPPP. Windows 98 D1. Okay, we need to get the directory here, but we can do copy D1 into the DOS directory. Copy. Yeah, we go to the DOS directory. Here it should run. Yeah. So we run it in, this is in real world mode DOS. It's not even in DOSBox, right? Although DOSBox, it looks very similar to the DOS we're running here, but it's not real world mode DOS. It's just still a little bit different. Okay. Yeah, I think there's some time zone issues with the DOSBox, because even they're the same executable, they don't go to the same time here, right? The time is incorrect. It's actually a problem with DOSBox. I think, okay. But here, you can actually run the real DOS, or in the DOSBox. The file size will also support both of them. Right. So that's it. It's just about the video. It's probably another very long video. I wasn't expect to be too long, but I want to show you the DOS things here because it's interesting. Right. So you don't actually. Okay, I forgot one thing before. So we actually don't need to just use it. We can actually use it using both cross torture. This is Canadian cross torture, right? But we can actually use the native the cross torture running directly in the Linux. If you just run Linux program, you don't actually need to install that with Windows and use Windows to compile it. You don't actually do that. They both works and it works perfectly fine. Okay, that's about the video. Thank you for